I've been working with IT professionals on disaster recovery for well over 20 years now, 12 of which have been at Storage Switzerland. One of the big challenges that we see as we work with companies on disaster recovery plans is really just understanding what their capabilities are, what the potential of the technology is, and what the expectations of the users are. And so clarifying those three areas becomes really important. So let's talk about that. So the first thing we have is what is your current capabilities? Right, so unlike a reseller or a storage vendor, we don't sell products, right? So we're going to look at what you have today and what can it do, right? And so that becomes a big thing. And then the next thing is, what is the current capabilities of technology? Right? Or what is the potential? How quickly could we recover from a disaster? How big of a disaster could we survive? Those sort of things all become sort of there. And there's another equation in here. It's really kind of technology over budget, right? Because with enough budget, we can accomplish almost anything today with technology, but most people don't have unlimited budgets. So those two have to work together, and that's one of the things we also help with. Now, the third thing, and probably the harder part, is user/organizational expectations. Essentially, what is the expectations of the users? How does that factor in? What are the capabilities of the technology the budget is? And how much of your current capabilities can you use to meet those expectations? So these areas in between here are what we call the gap analysis. And that's one of the first things we suggest that people do, is really focus on what the gaps are. And so to really help with that, there's really three components that we'll look at. If you make disaster recovery planning as simple as possible, there's really three things it has to do. One is it has to capture data. The second is it has to move data. And the third is it has to restore data. Now, there's all kinds of nuances in there that we could spend hours going through, and we do typically in our workshops and things like that. But let's talk real quickly about capture. So capture is essentially how many am I making copies of data? How often am I doing it? What's our frequency? And what does the storage device look like that's actually storing that copy? Right? Now there's different ways to do that, right? Two simple examples are backup, and the other is replication. Backup is that traditional once a night backup. Typically, maybe you're really aggressive and do two. It's a full backup typically on the weekends or once a month, and then incrementals nightly during the week. Replication is more of a real-time situation where we're making a real-time copy of data. So as data changes on point A, we're moving it and making a copy of it on point B. So that's that. And then a third one that has kind of worked its way in and kind of factors into this technology discussion is what I'll just simply, for now anyways, label as advanced backup. And that's the ability of modern backup applications to do granular, what's often called block level or change block track backups. So I can do these backups more frequently because I'm not moving as much data. So that gives me a lot of capabilities there as well. And typically in an environment, we'll use a combination of all three to meet whatever the user expectations are. Now, the second area is moving data. There's a couple things we want to think about when we're starting to move data. The first thing we always start to talk about is distance. Almost every disaster recovery plan that we've been working with, the first mistake is the distance to the secondary site is too close, because that secondary site could be impacted by the same disaster as the primary site. So we want distance. We want a lot of distance between there. And so that distance could be another facility of yours in another state or country. It could be a colo provider that you're renting a rack space from, or it could be the cloud, and we could talk about the different things that'll happen there. Now, the second thing is how you're going to move it. So now that I've put this distance thing into the equation, I've got to be very granular in my data movement. So going back to how we capture data really becomes important here. So for example, replication as a movement engine is actually kind of good because we're capturing changes as they occur. I can just move those changes across a WAN connection to there. Backup is not so good because I'm making big captures of data, and so I don't have enough bandwidth to be able to move that data across the network. So a lot of times here, when I'm talking about moving backups, I'm talking about a truck, or I'm using a dedupe appliance that will do the differentiation on the back end, right? So that's the two factors there. Now what's interesting is advanced backup, because it does this granular block level incremental type of backups, we're able to move that also in a granular fashion, very similar to replication. So those are some of the factors from the move perspective. Now, in restoration, once again, there's really two phases that we have to think about. One is recovering at the DR site, and then the second is fail back. So the disaster recovery is, we're at this, whatever this site is, we decided, the colo, the cloud, whatever, and we need to bring up virtual machines or full servers to return applications to service. Now, once again, this capture method impacts this. Typically, if I'm doing replication, I'm replicating to a live storage system at the DR site. And so recovery, if you will, is just attaching servers, getting applications reinstalled, and pointing it to the live volume that's there. Backup, I have a problem because now I've got data stored in a backup format. That backup appliance probably isn't suitable for recovery, so I need to restore that data to another appliance. That takes time. Advanced backup is, again, a nice blend in that it moves data at a granular level. It probably is storing it in a backup device or a backup appliance, but almost all of the advanced backup software applications today have the ability to do something called a recovery in place. So I can start the volumes on the backup storage. Now that changes things in how we look at backup storage. Again, probably a subject for a future video, but that's something to think about. Now, the other thing, and just real quickly to close, is failback. How do I get data back? What we typically see in a failback or recovery back to your production data center is one of a couple of situations. One is the data center's gone. That means you got 100% full recovery. In some ways, it's actually better because you don't have to, there's no variables here. You just got to move a whole bunch of data. How you do that data movement, again, there's different ways to do it. We could bring the new storage systems to the DR site first, ship them back, different things we could do there. The more challenging one is if the data center survives. Now, what typically happens in, I'd say, about 80% of the disaster recovery executions that we're involved with is the data center does survive. That's because you declare a disaster because there's a hurricane inbound and you're within the zone of strike, but in most chances, you don't actually get impacted, right? So your data center's there. So think about what happens. You have failed to your disaster recovery site. You're working, everything's going great. One of the things we always advise people to do is make sure you're doing backups at your DR site because now that is your production site. So data's changing, you're doing things. Now you have if you will, a backdated set of data at the data center, at the old primary data center. And I've got to somehow merge those two together. Now what's interesting is from a replication standpoint, once again, this actually works pretty well. We can generally reverse the replication. Most replication software will look at what's there, compare it to what is in the DR site, and update it correctly. Backup software, both advanced and regular backup, have a problem in that once you fail into the disaster recovery site and now that essentially becomes your production, you're running a separate backup job there. And so merging that backup job with the backup job that survived at the data center becomes very, very challenging. So it's something to think about as you design the plan. And again, a lot more to talk about here, but what we want to do is kind of set the groundwork as to what is the potential. You want to look at what your current capabilities are. You want to look at what the potential is versus a budget. So we can get things down to zero, literally, or we can, very affordably, we can do 5 to 10 minutes. And so that's sort of your potential. And the other big thing that we'll talk about in the future is how to manage user expectations. For now, though, I'm George Crump, lead analyst for StorageSwiss. Thanks for watching.